In this module, we're going to talk about business models that are specific to the defense modeling and simulation industry. Now, I'm not saying that these don't exist in other industries. I'm just saying that in our experience, these are the ones that we typically see in our industry and the sorts of things that as you work with vendors, you're likely to run across. Now, business models it's a process. Remember we talked about value chains earlier. So understanding this process is the key, and that's really, you don't need to know all the micro details, especially from the government side. We don't need to get into the micro detail of how a company is structured and how they're making money. But the business model must provide value at each link in the value chain in order to be efficient. There are a lot of business models that have links in the chain that really don't provide value, and that's where disruption can happen. Remember, we talked about disintermediation, where links that either have no value or have limited value are removed by innovators and restructured in some new way. Those opportunities are there. But if it's an efficient business model, every link along the chain is providing some sort of value. So our key here is we just want to understand the basics. That's really all we want to know here. So what we're going to do is, because modeling and simulation has some similarities with the gaming industry, we're just going to look at a quick comparison to it, and just as a way of thinking about how the different pieces and parts might fit together. So a simple flow model looks like this, where you've got visual content. So look at models, graphical models, and anything that has a visual element to it. And there's tools that go along with that. There are modeling tools that artists usually use to create that content. Then you have, I use the other word, models, which to mean any other sort of model. Right? There's software models, there are human body models, there are ballistic models, there are weather models, all kinds of models, and all these things go into something we'll call a runtime. It is the piece of software, it's the software running on your computer that actually makes the simulation work. And there's tools for building those. And then, of course, that rests with your hardware. And by hardware, don't think I just mean the PC or the computer or the tablet or the phone or whatever it is that you're running on. I mean input devices. I mean virtual mannequins. I mean hardware, haptic devices, displays, all these things. This is all hardware in our industry. And all this boils into our applications. And if you naively think that all you're doing is buying an application, and you're not paying attention to all these pieces that are behind it, then there's only a few business models that are going to fit that, and they don't tend to be the most efficient. In fact, they make you the most vulnerable. So as you look at the different components, those are the different bubbles in that last chart, there's a lot of different roles and responsibilities and associated tools with each of these. Like you wouldn't want an artist writing code, and you wouldn't want your engineers making your models. And you wouldn't want somebody else doing your verification of your software models. So you have different people doing different things along the way. And the point here is that unless you're going to go out and buy what we call, you'll see it in a moment, a turnkey solution, which is, here is my bag of money, provide me the whole solution, which may sound very attractive, but is often not the best thing to do. Unless you're going to do that, you need to know about all these different pieces, because you're probably going to piece together for your solution a set of companies that are going to provide different goods and services that together are going to meet your requirements. So let's talk through some existing business models that we know. We just talked about the first one, turnkey systems. These are typically proprietary. You're asking for the whole thing in a box, so the fact that it's proprietary might not even matter a whole lot to you. It can be open, or they can use open systems, but they're delivering an all-in-one solution, so you don't really care. And there's a bunch of companies that deal with these sorts of solutions. The next one up from that would be system integrators. So the system integrator is now you're sort of passing the buck from government. This is what I kind of believe the government ought to do, is do what the system integrators do, but sometimes you want to outsource that to a company. And there's a lot of prime vendors, prime prime contractors out there that specialize in system integration. They don't actually do a lot of the technology themselves. They integrate things. And don't think that's easy, because they have to keep their eyes on what is the best of breed of all the different pieces and parts, and have relationships with all these other vendors so that they can pull it together for you, the customer. It also can be open or proprietary, but the vendor is going to integrate existing products into some final all-in-one solution. So you're still going to get kind of a turnkey system, but you're relying on an integrator, and there's a bunch of companies that do that. The next up would be runtime tools. Remember, we talked about those runtime environments. So these are usually proprietary, licensed, often with additional runtime costs. This is something that we've been hoping for years would actually go away from our industry. This is where you use someone's product to build a runtime simulation environment, but then you do not maintain the right to an unlimited distribution of your software product. For every seat, that's the term they use, seat that you distribute, you pay the company for each one of those. So it's not like you put your executable out on the web and let people download it and use it because you've already paid for it. They wouldn't be able to run it. It would ask the system for a license, which it wouldn't have, and it would shut down. So, but these tools tend to be general purpose. You can lower your upfront costs because a lot of people don't want to write source code all the way down to bare metal all the time. But you can have a bigger back-end cost. So there's a number of companies that deal with this. The closest, and these are almost, I'm talking exclusively the modeling and simulation community now. Close analogy from the gaming industry would be a game engine, which is proprietary, usually has a big upfront cost, sometimes in the millions of dollars, and usually has associated tools like level editors and things like that. But very rarely, I've never even seen a case where a game engine puts a runtime cost on their product. So when you invest in a game engine, you now have the right to unlimited distribution. If you're going to ship 10 simulators to your customers, it's the same cost, back-end cost, as it is to ship 1,000 or 100,000. Runtime tools can be different. So that makes game engines particularly good when you're going to do something like what America's Army did, where they literally invested in a game, put it on the web, and let anybody download it. They needed that upfront licensing arrangement. And that was Epic Unreal, actually, that provided that for them. But if you look at VBS2 that the Army and the Marine Corps use, that's Bohemia Interactive, same sort of arrangement. And Gamebryo is the same. Gamebryo may have evolved since then. Next, content creation. So these are not tools. These are people you contract to create your content for you. So they can be proprietary if you let them, but you'd kind of be a fool to do this. You'd probably put this in your contract that you want someone to do the work to develop models for you, or terrains, or whatever it happens to be, in some standardized format. So if you ever want to change it at some future date, you have the right to do that. So they can be proprietary, but they really shouldn't be. These are not applications. It's just data. And if you're not smart, you're going to need to return to the vendor for enhancement, and you really don't want to do that. So you want to be smart about how you would do that. If you don't want to build an art shop to build your content, you want to contract it out. Be smart about how you write the contract so that you have the right to do whatever you want with what you've paid for already. The next is components. So these are independent components that are meant to use with a variety of other frameworks. So DI Guy it's an articulated figure module. So if you wanted to do an application that had crowds or articulated figures for squads of Marines or soldiers or what have you, you could buy just DI Guy and integrate it with other parts of your simulation and save the money of having to build your own articulated figure product, which would be extremely expensive. Havoc, for example, is physics. You want really, really high-end physics, you buy a Havoc license, which is just a part of your end solution, but it does a really good job of physics. Continuing on, we talk about content creation tools. So this is what your artists are going to use. If you have a group of artists who are creating content for you, these are not the models themselves, but these are the tools that make the models. So 3D Studio Max, TerraSim, TerraTools, Creator, these are all products that are in use in the marketplace today. The products themselves are almost always proprietary, with some exceptions, like Blender would be an open source content creation tool. But you sometimes don't care about that if they produce file formats that are open. So as long as the models themselves are in open format, so you can read them into any runtime environment you want, you might not care that the content creation tool is proprietary. Next is support and maintenance. What about a company that doesn't provide you anything other than supporting you? So I don't know of any good M&S examples, but Red Hat for Linux is a classic example of this. They have since got into some support products, but originally they were a support and maintenance company for people who didn't want to mess with the dirty installations and whatnot of the Linux you would download off of the web. They would provide all the service you need and would even do it for you if you wanted to set you up with your Linux installation. The next would be model libraries. So this is like contracting out your content, but you're not actually paying anybody for the content. You're just buying stuff that already exists. So TurboSquid is a good example. You can go there and look for models of vehicles and weapons and buildings and whatever else you might need. These are reusable models, always in standard formats, because if they weren't in standard formats, they wouldn't have a market. So these are always in standard formats of one form or another. The next would be open source. So these can be fairly low-level tools and libraries. Sometimes are not well supported, but they're entirely open. And when I mean open, I don't mean just an open standard. I mean open source, all the way down to the source code. So this could be something where the entire system is open, but it could also be something where just a piece of it is open. Like Open Scene Graph is a really good example. We developed at the Moves Institute, we developed Delta 3D. It was an open source game engine built out of other open source products. OpenSim is another example. So these are open source projects that you can leverage for your project. Interesting point to make that we're going to get to when we talk about open source later on is pay attention to the licensing scheme on this open source product that you use. If the open source license demands that the openness of the product be viral, meaning that anything that uses that open source product must also be open source, that means you can't do anything proprietary with it. You must make it open. But those are actually becoming less popular. What's becoming more popular are the modified open source licenses that allow you to build a closed or proprietary product that uses an open source product. And the last two are the hardware only. So these are folks, we use these all the time. Companies like Barco and Christie that do nothing but build high-end projectors for specialized purposes. InterSense does trackers. In medical simulation, you've got instrumented mannequins and all these other sorts of pieces of hardware. And then in some cases, there may not be software associated with it at all, maybe nothing more than a simple driver, and you have to build your simulation that drives their hardware. But these are hardware companies. They focus on the hardware with minimal software just to integrate their product so that you can write your own simulation. They just provide the hardware and the driver to drive the hardware. And then last, you're going to run into research and development companies in M&S. So these would be universities, other government labs, and there's a number of small companies that fit in this category. Their business is to do R&D. So they can be your R&D partner if that's the type of money that you've got and the sorts of things you want to work on. Aptima is a company that we've worked with on a number of occasions. The Georgia Tech Research Institute is a great example of a university research and development group that often partners with the government to do research and development. So in summary, just walk through a whole bunch of different models that you might run into. It's important to note that these models they're often not mutually exclusive. You're not picking one. This is sort of an ecosystem, and the things that we do in M&S are so sophisticated now that you're often going to work with a variety of different companies that have different business models. You just need to know what they are. So you're going to see mixes of them in different businesses. So an example might be like a tool vendor that also does maintenance and support, and they'll charge you for maintenance and support. So that's a moneymaker for them. You want to keep in mind both immediate and downstream revenues that are associated with each model. This has been an ongoing problem for government, especially when you end up with a government organization where people are rotating, like let's say every couple of years or every 3 years. You have to be very careful of not making decisions that might be good for you on your tour there for a few years, but are going to be a nightmare for the guy behind you. So you want to make sure that like turnkey solutions are really attractive sometimes. And in fact, in a lot of cases, the vendors will make them even monetarily really attractive, really cheap. Here, buy my turnkey solution. Don't mess with anything. Just cut me a contract, and you will have a product in your simulation facility in weeks, not months or years. Doesn't that sound attractive? Well, sure it does, until you find out what the downstream costs are. The fact that you just bought into a legacy system, you now have no choices on where your maintenance and support is going to come from, and that company now, as long as you're going to run that simulator, they own you. So you might not want to do that. Now, some of these involve lock-in, like I just described, but others do not. But that's why we talked about lock-in earlier, so that you understand what the mechanics of lock-in are. And I'm not saying, in some cases, you might not care. It might be a situation where, you know what, I've got a certain amount of resources, I've got a fast-burning requirement, I've got to get a product in here fast, I don't care about lock-in, because I'm just going to dispose of it in a short time anyway. Hey, you asked the question, you know the answer, you went into it with your eyes open, go for it. But in other cases, you really don't want lock-in, and you want to make smart choices to avoid it. So flexibility is sometimes sacrificed for rapid deployment. We talk all the time about what happened in the dot-com boom in the 90s. Is companies were grabbing what was called Microsoft Back Office, which was a suite of tools that would let you rapidly, using Access databases and other quick and dirty tools, you could build a beautiful website. And companies, startups were using those products all the time as a way of mocking up their idea for what they were going to do. Then they'd show it off to their investors, and the minute their investors signed on and they got their money, they threw it all away and went back and built it the slow way. That is, piecing together Java backends and Oracle databases and other things that were much more robust, took a lot more energy, a lot more architecting, but they know that that investment is going to pay off in the long haul. So they got their flexibility in the long term, but they wanted rapid development in the short term. So you want to understand how your contractors and your vendors are making money. And again, not in gory detail. You just want to know basically how they're doing it. And it's important that they do. Remember, we're government, so it's important that our contractors and vendors make money. We're not happy if they're not making money, because if they're not making money, they're not going to be in business, and then that means they're not going to be there to support us. But we want to know how they're making money, so that it's equitable, that it's reasonable, it's responsible, it's auditable, and that we know exactly what we're doing. So we want to constrain that value to the government. We want to optimize that the best we possibly can. And if there's one thing you want to remember from this module, that's it. Just understand a little bit about how your contractors and vendors make money, because I think it's going to help you to think about how you piece your team together to meet the objectives that you're looking for.